Alrighty, now, oh man, now I don't know what one of the values is, so I'm going to have to do some elimination. So let's number our equations. So I'm looking for that one equation and that one variable that seems like it's going to be easy to cancel out. And ideally you're looking for a coefficient of 1. Now if I look in equation number 1, they all have coefficients of 1. However, if I look at the x, so if I want to cancel out with this equation, I'd have to multiply the top one by -2. And then separately, a side problem, I have to cancel out the x with this equation. I'd have to multiply it by -3. So it's doable. I just have to do some multiplying. Same with the z's. Well, here I'd have to multiply one of them by -1 to get a negative z. And when I try to cancel out the z with this bottom equation, with the other equation, I'd have to multiply by -2. So I have to do some multiplying. So those are all good, reasonable ways that you can go about this, folks. But check this out. If I use equation number 1, which has a positive y, I have an opposite y right there. So I can cancel out the y's with equation number 1 and equation number 2. Remember, equation number 3 needs to get brought into this fold for a second cancel, or for a separate cancelization of the y's. And again, if I use equation number 1, it will cancel out with equation number 3 as well separately. So I am going to try to eliminate the y's. That's my goal here. But you could choose a different letter if you wanted to. It just means that you need to do a little more multiplication. Now, whatever variable you're multiplying, you need to use all 3 equations when you cancel out the 2 sets together. So in this first set, I'm going to cancel out the y in equation number 1 and equation number 2. So equation number 3 is off the hook here for a second. Make sure you copy things down carefully. I think I did everything correctly there. So look at this, folks. Now I am going to be able to write a new equation without y's in it. So I get 3x plus 2z equals 9. So just hang on to that equation, folks. Just let it sit there. That's the combination of equations 1 and 2. And if I had to multiply, it'd still be a combination of multiples of equations 1 and 2. But I need to do that same process using equation number 3. Excuse me. So I have to use 3y minus y plus 2z equals 8. Now, I could use, so I have to use equation number 3 since that wasn't used in either one of these. I could use equation number 2, or I could use equation number 1. It's up to me. Well, I'm going to choose to use equation number 1 because it has a positive y, which will eliminate the negative y right there when I add them together. So I'm going to choose to use equation 1. You would have to multiply equation number 2 by -1 to create opposites, which there's nothing wrong with multiplying by a -1. It's just a little more work, another chance at making a boo-boo. What is wrong with this? What's wrong with this is how I copied down equation number 3. I noticed when I started to combine that I didn't have like terms on top of each other. That's because I copied the x wrong. So here we go. We get 4x. Again, the y's cancel out, so then I just have plus 3z, hello, equals 13. The y's are gone here as well. That's the first step and probably the most difficult step, is figuring out how to cancel out one of the variables. So now I bring this new equation that I created by eliminating the y's from my first system right here and the second equation right here. I'm going to put them together. So I'm going to write them on top of each other. So what I just did was kind of like my big step number 1. Now I look at this new system, like equation, I'm going to call this A and equation B. I put A and B on top of each other. This isn't like a technical thing. You don't actually need to put these letters next to stuff. It's just trying to help you see the process. And so now, folks, you figure out how you want to either figure out x or y. X or z here. So I'm going to choose to eliminate the z's. This is totally your choice. But if I multiply this top one by 3 and the bottom one by -2, I will get opposite z's. So I get 9x plus 6z equals 27. And on the bottom, I get negative 8x minus 6z equals negative 26. So notice the z's will cancel out. So I can figure out here that x, because 9x plus negative 8x is x, equals 1. Awesome. X equals 1. Now that I've found what x is, I can go back to the two equations I was just using, either this one in blue or this one in yellow, either or, and check out those equations. They have an x and a z in it. Well, since I know what x is, if I plug in 1 for x, I can calculate z. I'm going to use the top one. So I'm plugging in 1 for x plus 2z. Whoa, I always want to write y. Naughty. 2z equals 9. So 3 plus 2z equals 9. We're going to get 2z equals 6 when I subtract 3. So then z has to equal 3. Does that work? I kind of did that fast. I might as well just, yeah, it definitely works. When I plug a 3 in, I get 6. 6 plus 3 is 9. So there we go. So we've got 1 for x, 3 for z. Now I got to figure out y. So I need to look for an equation that has an x, or that at least has a y in it. And so I could use any of these equations that we started with because I know what x and z are, and this looks like the easiest one to do. So I'm going to use that equation now to figure out what y has to be. So let's see. X plus y plus z is 5. So 1 plus y plus z is 5. So that means that y has to equal 1. So my ordered pair is 1, 1, 3. X, y, z. And if you plug them back into the other two equations in the system, it should be correct. And I think it is. There's the solution. Let's try that again. Alrighty, so here, I look at my z's, they all have coefficients in front of them, other than 1. That's going to be kind of rough. Same with my y's. My x's, well, like, this one first just has a positive 1, which is easy to work with. So I'm going to choose to eliminate the x's. That will be the easiest. And wow, equation number 1 and equation number 2 have opposite x's already cooked up for me. That's awesome. So I'm going to add equation number 1 with equation number 2. So I get x plus 5y minus 2z equals negative 16. And on the bottom I get negative x minus 7y plus 3z equals 23. So we get negative 2y plus z equals 7. So you're like, what am I supposed to do with that? Just hang on to it. At least we have this new equation that only has 2 variables in it, right? Thank goodness. So now I need to create another equation that just has 2 variables and gets rid of the x's, so I can create a new system with just y and z, because we know how to deal with that. Now I used equation number 1 and 2, so I have to use equation number 3. There is no ifs, ands, or buts about that. You've gotta. Now you do have a choice on what equation you want to use on top. That's a negative 5, folks, and that's a positive 5. I don't know why that looks so funny. So so the opposite of 3x, because I have to get rid of the x's, so what I need up here is a negative 3x. So honestly, folks, I'm going to use equation number 2. Yes, it has a negative x, and I want it to be a negative 3x. So I'm going to take that equation and I'm going to triple it. I'm going to multiply everything in that equation by 3. So this is essentially equation number 2. Of course, it's tripled. So we get, I'm going to steal. Can you do me a favor and close the door on the way out? So we get negative 3x minus 21y. Ooh, and here comes the z. Plus 9z equals 69. Let's see if I tripled everything correctly. Yep, we are good. So now we can add these equations together, and the x's cancel out. Whew. We get negative 31y plus 4z equals 74. Let's double check our math. I think that looks good. All right, so we created these two new equations that only have y's and z's in them, no x's. So now I can take these two new equations. This is like my second big step, although you would probably call a lot of those things we just did a big step. Take this equation that we just kind of hung on to, take this equation we just created, and put them on top of each other. We've created a new system of equations that will make it easier to figure out either the x or the y or the z. Once we figure out one of those variables, we can start chipping away at the other two. So let's see here. Oof, look at the coefficients there. A 30, a negative 31, and a negative 2. No thanks. So I'm going to try to get opposite z's by multiplying the top equation by negative 4. So I'm going to get positive 8y minus 4z negative 28. When you multiply by a negative number, folks, all of your signs in the original equation should be opposite. So this should become a positive, which I do. This should become a negative, which it did. This should become a negative, which it did. It's a good check, because oftentimes the mistake we make when we multiply by a negative is just the signage, not the actual numbers. And then I bring down the negative 31y, positive 4z, and the positive 74. So now we add like terms together, so we get negative 23, that was hard to write, negative 23y. The z's cancel out, hip hip hooray, equals 50, 40, oh boy, this shouldn't be that hard. What's the difference between 46? That'd be a positive 46. There we go. So then divide by negative 23. We get y equals negative 2. All right. So now we found what y is. Remember these highlighted equations, which are also over here? If we know what y is, we can use one of these two highlighted equations to figure out what z is, because there's only two variables in here. And I really like this equation, because look at the small values there. So negative 2 times y. Well, y is also ironically negative 2. That's a coincidence. So we get 4 plus z equals 7. So z has to equal 3 then, right? Awesome. And now once we know what the z is, we already know what y is, we got to find which letter? X. So where is there an equation that has an x in it? Oh boy, we got to go all the way back to the beginning. And I like the top one better because x is positive and the numbers are fairly small. So here we go. We're going to use equation number 1. I'm going to write it down. X plus 5y equals minus 2z equals negative 16. Okay, this isn't working for me. Just shove that to the side for a second. Group it in case we need it for some reason, but I don't think we will. Let me write that a little bit bigger. It's not fair to get all the way through this and then not see what's going on. X plus 5y minus 2z equals negative 16. I'm struggling with my letters. See why I'm a math teacher. Good thing I don't teach English. So x plus 5 times negative 2 minus 2 times 3 equals negative 16. So we get x plus negative 10 minus 6 equals negative 16. So x plus negative 16 equals negative 16. I add 16. I get x equals 0. So I'm going to circle that. Now that's, again, not my final answer. We're looking for the solution to the system. So write them together as a coordinate pair. X, then y, then z. There we are. Beautiful.